you accept it?
Yeah.
Write down your reporter, your team members, what they can do. Okay, the reporter has 5 minutes to prepare.
Oh, sorry, wait a second. You want to start now or you want to wait another 3 minutes?
Wait.
Okay.
Sure. I think I can start this.
Okay. Go to the next stage. Go ahead.
Okay, so for this round, I'm discussing the questions in Christian catapult. So our problem statement will be place an object on a large air cushion and drop several other objects in such a way that the first object is catapulted away. Investigate how the extinct velocity depends on relevant parameter. So we are focused on some questions and some things that we need to focus. And first is a question that what will be the highest point that ping pong ball could get? So we are making the variable about like what could be the highest point that ping pong ball could get. And second, there are many factors that could cause and affect the height of the ball. So I mean, the height of the ball that ping pong ball can fly will affect by many factors. And third, the air amount could hand on will connect to how the ping ball will bounce throughout. So, okay, so for the observations that we are seeing in my experiment. So for the observations that in the experiment, I could see that their air cushions has been squeezed. Just because for the air cushions, I was like using the plastic bag. So I put the air in the plastic bag and become an air, most likely become an air cushion. So when the things is falling down to the plastic bag, and it changed the shape. So we note there is the air movement inside the plastic bag. And for the ping pong ball has bounced higher than when the things fall. Just make because we have different factors, like the height, the things that fall down to bounce the ping pong ball. So I could actually see that when the heavier or when the height of the things is falling, the ping pong ball does do faster and like fly faster. So I could see the comparisons between it. And for the higher things, whereas the ping pong ball seems to bounce higher. So like a ping pong, this is what I just said. And ping pong ball, yes. So the possible variable. Some I will have talking about 3 variables that will affect the amount of the air in the air cushion. So there have different amount of air in the air cushions. So I will put in different volume of the air in air cushions. And it will affect because the amount of the air in the plastic bag, and it will affect the movement. And the substance weight. So because we have 2 substance, one substance is like falling down, and other substance is flying up. So the substance of the weight is the substance that fall down. And for that substance, because the weight is different, so if in the same speed, if the weight is increasing, then the force must be increasing too. So if the force increase, then the force increase, then the things that the ping pong ball that fly up might be increase their speed. For falling things height. So because we know if the substance stay longer at the air, it will increase more speed, and it will also affect the force. Experiment. So research problem. So I know this is our problems that we are figuring out. So we are figuring out like what are some factors that will affect the external the speed. And mainly is knowing like the speed that will calculate. I will calculate by video and see the extinct speed and know how to. So we will know what different factor might be affect in the speed. So research objective. And theory. So we all know like when the things fall down, the plastic bag will compress. So when we compress, then inside the plastic bag will have higher pressure. So inside the higher pressure in the plastic bag want to strengthen the plastic bag. So when we compress the plastic bag, the high pressure in the plastic bag airs will pull someplace out to the plastic bag. And so if the ping pong ball is in the place that bounce out the plastic bag, when a plastic bag is bouncing out, then the ping pong ball will be fly. And so Boyle law, we call it the Boyle law. So this law is talking about like when the pressure is compressing, then the higher pressure inside the plastic bag will also increase. And equipment. So we will have ping pong ball and the different counterweight. And the counterweight will be the substance that fall down. And the plastic bag will be the air cushions. And rubber band is like making the volume in the plastic bag will be the same, so it will tie it up. And the rope, I will using the rope to making when the thing is full, and I could control when I want to fold things up. So the rope will be tied up to the counterweight. So when I want to make the counterweight fall down, I could control the time. And the pulley will be the things that, because the rope will connect to the counterweight and across the pulley. And the blocket will be the same stack, making sure the plastic bag not move. Okay, so experiment produce things. So I will, just like what I say, I will connect the rope to the counterweight and across the things to make sure that every experiment have the same dependence. So my hypothesis is that because we all know in the plastic bag the air will have the movement, so if the things are compressed, then the other side of the plastic bag will push it up, and causing, I think for my hypothesis, I think that the ping pong ball will fly. And this is my data analysis. So we have 30 cm and 50 cm, and this is the height of the counterweight. So as we can see, we are determined the speed, the starting speed. So the starting speed in the 50 cm, the height will be 562.17 cm per every second. And for the 30 cm will be 538.87 cm per second. And when we are decreasing, other variable is decreasing the gas, the air in the plastic bag. So if we decrease it, we can see the speed is increasing. And this is the data. So it is a pretty good thing that we can see when the thing is pushing up, and it will start making slower. And this is my arrow, because we can see this variable is pretty much weird, that because as the start of the speed, it must be higher than the ending speed. Conclusion. So for the conclusion, we know the height of the substance and the pressure, the amount of air in the plastic bag will affect.
Turns out, the opponent had 2 minutes to ask the question.
Okay, so here's the opponent. And the first question I'm going to ask the reporter is, okay, so do you agree that the whole problem statement is about to optimize the exit velocity of the object. Agree or not?
Agree.
Yeah. Okay. So there is another question that do you agree this is about the change between the potential energy in your experiments, the change of the potential energy converted into the other object's kinetic energy. You agree or not?
So you mean
You just need to say agree or not. Okay, thank you. So another question, do you measure and maintain the same air pressure undergoing in your experiments?
can you say again?
Do you maintain the air pressure in your experiments, and do you measure it precisely?
Okay. For this question, because the air pressure is not, because I am not changing the air pressure factor. Because,
Okay, so you didn't change the air pressure factor.
Because in the slide, I'm talking about
So do you control the air pressure or not?
no.
No. Okay.
Yeah, this is not air pressure.
So another question: do you think the temperature will remain the same during your experiments, or there will be change in the temperature? Yes or no?
I'm not sure.
You are not sure.
Yeah.
All right. And since my question is over, then let's move on to the next session.
You have 3 minutes to prepare your question.
Upon the text flow.
Honorable juries and fellow competitors, I'm the opponent from Team Jinchen High School, Alphas. And today I'm going to oppose problem number 16, quotient output. So first, we'll be talking about the Alright, so first we will be talking about the problem statement, where problem statement requires us to discuss the relationship between the drop of the second object and the first object's exit velocity, which opponent thinks is the most important factor, and about the reporter structure. They first introduced an observation video with a quotient squeeze, and the shape will be changing. And their theoretical model, they offered us the pressure strength, and also they use the Boyle's law. And about the setup, they use ping pong ball, plastic bag, and their pulley and rope. And they do some variables such as amount of the air and substance, weight, and also the falling height. And in the conclusion, they made the conclusion about the height, the substance weight, and the air amount affected. So the strong point of them are they matches the problem statement, and they has a great fluency, and they listen the data of the experiments. And their weak point is they have no quantitative theory and a conclusion, a clear conclusion. And their experimental video is unclear, and they have a good time management. So let's move on to the discussions part. Alright, thank you. And I'll be asking the reporter up to discuss. So, okay. So first, what do you think about the height, the relationship between the height of the object you drop and the other objects that is bounced up?
Okay, so go to data. So you are asking the data part.
I'm asking your opinion after your experimentation. What's the relationship between height and the velocity?
So for my experiment, I think that we have like two different factors. One is 50 cm, and this is the height that we broke down. So for me, I think that if the higher the things is falling down, we can also see in the data that the speed in cm per second is increasing. So it is not accurate in here because we have two, but we can guess so that have the increasing of the cm. So if we increase the cm, I think the speed will increasing also too, because if we increasing the cm, the things that stay in the air will last longer. So if it lasts longer, then it will have the increasing speed.
Okay. Okay. I now get your opinion. So your meaning is that when it comes to the factor of height and when the acceleration is longer, that the object will get a more higher speed, and which leads to the exit velocity of higher exit velocity, right?
So yes, because
yes.
Increasing of the
yes, I understand your point.
Increasing of the speed, it will affect the force of the things. So if we affect the force, then the ping pong ball must be fly
opponent
lower.
now understand reporter's opinion, where yes they but the opponent doesn't think that it will affect the force. It affects the energy that is given to the quotient, because for the force that can I use the blackboard, please? Yeah, thank you. So about this factor, under certain height, the force of this object will always stay in a simple form of entry, right? Okay. So then, if it accelerates, the acceleration is the gravity, the gravitational acceleration, right?
You can just choose.
Yep. So, which your opponent didn't agree with your points about the force applied on will increase, because the force is remain the same.
Okay, so because we know if we increase the speed and the force the force that go down to the passive back must have increased because in the same time if we the speed increasing, so if from the data we can see that the speed have increased from the data. So we are doing average conclusions from the data that we make the experiment.
So, yeah, but the opponent has an opposite opinion, but it's okay. Let's move on to the next discussion because so the opponent's view will be the energy that given by the second object will be affected, but not the force. Okay, but the reporter doesn't think so. So the next discussion will be, so why is your velocity changing to varying during time? Can you raise what is the factor that affects your velocity?
So we know in the time is changing from this. So we are calculate when the time is changing from this to this, and we know how much time it is making. So and we can calculate the speed.
Oh, so this speed is the one that's dropping or the one that's bouncing? The bouncing, but why does so then why do you use the data that is from like 28 seconds of the bouncing? Because like the problem statement said, we should measure, we should discuss about the axis velocity, which it shouldn't be measured at a certain time like this.
Okay,
What's
so
your opinion?
for my opinion, I know that because we want to clearly understand the thing is fine. So from the speed of from the speed data, we can see the speed do have decreasing. So we know if we decreasing, then we should actually know this data is accurate because when the ping pong ball is flying out, we know the speed must be decreasing by the gravity. So if we do it like this, we can make the audience know more accurate that this experiment will be true.
Okay. Then the opponent would like to invite the reporter to the blackboard, and from the opponent's view, here is a cushion where we drop our thing, and this one will bounce up. So the first force, which converts from the energy and the force from this one, will convert to this one. And so about the problem statement, we should be discussing the axis velocity, which the velocity leads to the axis leads to the opponent thinks it leads to the initial part of the axis motion, and we should be discussing this because from your data, if it's not discussed like this, you cannot ensure that the comparison between your 30 centimeters dropping height and 50 centimeters dropping height will be comparable because there, in opponent's view, the velocity is changed and that will varies from its acceleration. And if we consider another term, which is the air drag, and also the pushing force, there will be two accelerations, which the air drag will accelerate it. So not only by the gravitation of three components, there will be three components and two decelerations and one accelerations. Do you agree on it?
So, I mean, because we know you have increased like gravity.
Yeah, here's the gravity, and the gravity will give it a deceleration.
Okay.
Yeah. So you agree that there is two decelerations, which the opponent doesn't think that your data analysis is correct because it should be discussing from the exit point, because when the time comes to too much, like 28 seconds and 48 seconds, the two components may have in effect the velocity so much, because like the air drag force is related to the power of 2 of the velocity, which when this velocity is higher, the deceleration is higher, and the gravitational force will remain the same, but here will be the main thing. So do you agree about this part?
So, okay, so we know, because for the questions, the statement is made the extinct velocity. Yes, the question statement is what some factor will affect the extinct velocity. So it is not important for that. So for my graph, I do it like this to make sure the audience know, like this must be a true experiment. So, but the main things that the main factor that we are discussing must be this variable, the extinct velocity.
Yeah. So yeah, at this point, I agree that we should let our audience know more clear about our experiments presentation. But what I'm discussing about is that I need to suggest the reporter to get his exit velocity from an early stage of the bouncing, because like I said, the drag force turn will affect so much after time varies. So these two data shouldn't be able to be compared, and that's what my point is. But I admire that the reporter showed that his greatness about presenting his more clear presentation to the audiences. And
but okay, so for this factor, like for like I know for the extinct velocity is the main point that I need to show to the audience, and for the things is the extra point that I'm discussing. But I'm not going to compare this factor to this. I only compare this factor to this to know, because this is the things that I'm going to.
Oh no, what I mean is that when here you got 48 seconds and here's 28 seconds, the deceleration will affect the velocity so much, or maybe you can just change it into the initial part of the bouncing, which we can get a more accurate data to compare.
Okay, so
Stop.
Alright, thank you.
The opponent want me to summarize now.
Okay, so during our discussion, we have discussed about the problem statement, which require us to do the analysis about the exit velocity, and the opponent now there has a different opposite view from the reporter, and because that reporter's data is chosen in different time dependence, and also that their air drag force and other deceleration terms are related to this part. So this data that the opponent doesn't think that it should be compared, and the opponent suggests that reporter should have a measurement about the initial exit velocities. And we have also discussed about like factors about the heights, why height will matter, and that's all of my concluding. Thank you.
Okay. Reviewer, you have 2 minutes to ask the question.
The reporter, please turn to the statement, please. The statement shows that statement, public statement. It says that you have to. It says that the several objects dropped on the cushion. You investigate that. I mean the objects that falls. The problem says that there are several objects. You investigate that.
So, the drop several.
Yes or no? Yes, you drop several or just one?
Yeah, I dropped several object because
Okay.
I changed
Alright, that's
the
the question.
volume of the thing. So it's
And how do you calculate your data? You say you use video to analyze. And how do you calculate using software or something?
I use the app that the tracker.
Okay. And you show your data, please, the plane, please. And you show that the velocity will change through the time. And what's the relationship between them?
So okay.
Sorry, I mean the height. You change the height, right?
Yes.
And what's the relationship between the height and the velocity?
So the height, we can see the increase of the height will increase the speed.
I mean the relationship is linear or the equation. What's the line be like?
So if I put the x volume to be if I put like the cm, the height of the falling things become the x variable, and put the speed to the y variable, then it will have the linear equations that's going up.
Okay.
But and for this is the different factor.
Yeah,
We also have the
That's
the
we move on
things
to the next.
that decrease.
The opponent just said that if you think that temperature will affect the phenomenon, you agree? You think that will affect the phenomenon, or you don't know?
Okay, so because for the temperature, I didn't put temperature in my factor.
Oh, okay.
So I cannot sure, but
Okay.
I do control the temperature variable because if I do
Okay,
it
fine.
in a room,
It's okay.
so I control this factor.
Okay. What do you think?
About temperature, yeah. I think when the air is pressed, there will be temperature produced, and that is an important factor.
Yeah. Okay, thank you. And do you think that material will affect, yes or no? The material of the cushion, yes or no? Both.
I think it will.
Yes.
Time's up.
Thank you.
Okay, River, you have 2 minutes to prepare. low signal.也是吗？看什么？啊，不要乱猜。马上下去找人。No， 不要过。都不行，都不行。
先换线。
先换线。好。先把它拆掉，哦对啊，要把这个拆掉。差点没
为什么这个线这么
603，目前是603。
好，电脑。哪一台？
现在改变多，这边是用这个，对，但也有切换，还没有接触到，接触到也会亮灯。
其实好像，所以3台都没接吗？
不是，那台是直接，
这两台都不行，我们被迫用到那台线。
两台都不行。
对。
这个没有接，没有接它不会显示。
哦，刚刚我们接了，接完了之后才传到那边去了。
那你现在在接？
来，拿过来。你的拿过来。好，接住，你直接先接。
然后这样接。
上一次是这里，是这里。
你先接上去，把这个报告完，其他的你要把这个事情就是那边有事情。
我拿一台新的来，
你先控制时间。
好，要下一个吗？
好。
I'm the reviewer from Team Resonance, and here's a problem statement. Place an object on a large air cushion and drop several other objects in a such way that the first object is carried away. You have to investigate how the atom velocity depends on relative parameters. And here's the theory. the reporter used. He used pressure to push the object exit, and he used Foyle's laws to describe the pressure change. And the right side is his experiment setup. He used ball, a counterweight, and a plastic bag. And the method he didn't explain well. And here's the strengths. Reporter used a lot of experiment to prove. And the setup is good, but the result isn't seem well. And the suggestions, he lacks quantitative comparison between various experiments, and he lack of explanation for experimental results. And the analysis method, I just actually
所以现在能换吗？
factor to
现在能换
use,
吗？
but didn't explain well also. And he has no model to describe his phenomena,
好，等你。
and lacks basic picture or a simple explanation of the phenomena. And here's the opponent summarized.
好了，
The
叫。
strength asks precise questions and leads a great discussion, and well understanding of reporter's report.
要换什么？
So here are some distractions. You wasted too much time on a single question on the discussion. Here's the discussion. The opponent asked, the temperature will affect. The reporter will not sure, and he answered, yes, but not described very clearly. And I think that it will affect due to the law or chemistry that as the pressure gets higher, the temperature gets higher, or the pressure also gets higher, PV equals nRT. And the opponent asked the relationship between drop height and exit velocity. And the reporter just answered the height bigger and the exit velocity also bigger. And I kind of agree with the reporter, but I think it is a explanation. I don't think that it's linear, because the velocity also means the force it costs, and the velocity is as the square root of 2 times gravitational acceleration at height. So it shouldn't be a linear correlation. And the discussion, theta is not exit velocity. The reporter agrees, but not affect a lot. But I think I agree with the opponent. The data shows just like an average speed, not the initial speed that the object being pumped out, catapult out. Sorry. And discussion, and I asked, do you throw several objects? And yes, because this problem statement asks to. And I asked him out to get the data, use tracker. And the relationship between is linear, and I just said I don't agree with you. And material, both of them agree that will affect, and due to its different intensity and the compulsion, and it will have different kind of energy waste. So the velocity will also be affected. Thank you.
Thank you. Then the reporter has 2 minutes to remark.
So first, for my things, I think pressure is not a factor, because for our plastic bag, in the plastic bag, because if we decrease the air inside, then the plastic bag will also decrease. So the volume decrease. So the pressure didn't change if we decrease the air inside the plastic bag. So in this factor, like say the pressure is not a factor. And I used a different way to show the data, so I could be more accurate. So for the opponent, they have the air resist. Okay. So first, the air resistance from the boat is very small. So for this, they have said around that it will be a very big effect on the air resistance, but it is not. So, okay. So that is also why we use. Okay. So for when you ask a question, they only say yes or no, and even ask for the opinions for us. But for this experiment, we do say the fact, not opinion.
Time's up. Okay, question on the jury.
Question for your opponent. You question the reporter's way to measure the effective velocity. And how would you measure the effective velocity of the first object?
So first I will use like what the reviewer said, tracker, to track the initial active motion, which will vary from like 0 to 0.5 seconds to ensure the first acceleration and the first velocity is measured.
And the same question for the reviewer.
Kind of agree with the opponent that we rather use the slow motion to get more short time change of the velocity, not the motion and the velocity.
I have a very big question. When you use the tracker, you only have the two-dimension diagram, right?
Yeah.
But actually, the thing is dropped in three-dimension space. So your velocity is just a component. How do you get the real final velocity? You see my point?
So like for me, we know for in the tracker, they will have a line that we are saying if it is 6 cm and or it is 10 cm. So if we put that line in the middle part, then it will become like the average, because in the start of the speed, and we will do it in the same place of the line, and we will be more accurate because we are knowing the extent for the speed of the extent. So if we put the longs like 6 cm in near the place that extent speed, then it will be more accurate.
For the cushion, if we change the initial pressure of the cushion inside, then what will be the result? How do you think?
Because for me, it is not. I didn't code it in a pressure. It is not pressure.
As I said, if we change the initial pressure of the cushion, how do you think the result of the velocity, the exit velocity? How do you think? How do you think?
I will think that it will bounce. It might bounce higher.
Why?
Because when if you have the higher pressures, when the things fall down, the things also will compress.
How do you think?
So in the opponent's view, we think that when the initial pressure is changed, that the density of the air or the contained objects will be changed, which will lead to the energy's conversion rate from the first object and the second object. So there will be, and also the pressure change will lead to like the acceleration of the particles inside the bag, and
How do you think?
the energy. Oh, okay. So here is second 2 points: energy conversion rate and also the energy decrease.
And then the speed
Yeah. Oh, okay. So the
will be fast or slow?
they'll be faster.
I think the faster.
Why?
Yeah, due to the energy that the air has to move, right? So the shorter the air moves, the energy waste will be lesser, will be less. And yeah, thank you.
Any question? No? That's great. Proceed. Okay, let's go to it. For the reporter, 43554. For the opponent, 75776. For the reviewer, 64765. Wow. Okay, let's take a break.